Okay, so our goal now is to use this principle of equivalence to argue that we can explore physics in an accelerated frame in order to get a sense of what gravity does to space and time. So let's say that we are in a laboratory. So this is our laboratory, and here you are in the lab, and let's say that, so it's located somewhere in the X position, the center of the lab here, and the bottom of the lab is at t equals 0 at some value y naught, a vertical coordinate, and the acceleration here is g. So we can say that the acceleration is g, right? It's positive g. The laboratory is accelerating upwards at g. So we can say that the acceleration in the y direction is just equal to g, and therefore we can integrate and say that the speed is just the integral of that, gt plus some initial speed, v naught. Let's say that we start at 0 speed at t equals 0, so the equation just looks like that. That's the speed, and the position is therefore, we integrate this and we get 1/2 gt squared, and initial speed is 0 here, so it's 0 here as well, and so we just have to add the initial position there as the constant of integration. So this is the equation for the position of the floor of the laboratory. But we want to explore this from the perspective of the lab. So from the perspective of the lab, we are in an accelerated frame, and we should see the effects of gravity. So let's change coordinates to y bar. So y bar is just a y value, but we're going to subtract the 1/2 gt squared, and so the speed of the lab is y dot minus gt, and the acceleration of the lab is y double dot minus g. Of course, y double dot is equal to g, and so of course this is equal to 0, and y dot is equal to gt, so this is also equal to 0. Of course, from the perspective of the lab, an object that's sitting on the floor there has 0 acceleration and 0 speed. So these objects are unaccelerated in the lab. But for objects that are at rest in the lab, so there's an object that's just sitting there in xy space, and of course the lab is accelerating upwards. So let's consider objects such that y double dot equals 0, right? So an object that's, it could be moving at a constant speed upwards, but let's imagine that it's just fixed at some y value. Then we would have that in this case, right, because of this equation, for objects that are not participating in the motion upwards, the accelerated motion upwards of the laboratory, then this becomes minus g, and so it looks like we've created a uniform gravitational field in the laboratory. All objects seem to be accelerating downwards from the perspective of the laboratory. So again, The idea is that we've created a gravitational field, we've created a uniform gravitational field, and we're going to explore the effects of gravity on space and time. So in other words, if no gravitational field exists, we've created one by jumping into an accelerated system, an accelerated laboratory, or we can think mathematically and talk in terms of a change of coordinates, where we've changed to these coordinates, and from that perspective we have a uniform gravitational field. So we can then change back to these coordinates or jump out of this accelerated frame and therefore eliminate the uniform gravitational field. So it looks like there's this question, is gravity really a pseudo-force? And the answer is no, because a real gravitational field is non-uniform. And so these kinds of coordinate transformations create a uniform or eliminate a uniform gravitational field, but you can't do that for a non-uniform gravitational field. For the field of a spherical object like the Earth, that's a non-uniform gravitational field, and the coordinate transformation is going to be different at every single point. Okay, and so by analogy, it's like saying you have a sphere, and at every point, here's a flat sheet of paper. It makes contact with the sphere at one point, but it's a different sheet of paper that makes contact with that point, and so on. Every point requires a different sheet of paper. And so it's not one overall coordinate transformation that will do the job. So our next goal is to bring acceleration into or onto the space-time diagram so that we can explore the effects of gravity.